Today we're talking about 12 volt systems without all of the extra jargon. I'm Jimmy from Coreoffroad and welcome to Shop Talk number 3. Today I'm joined by Kieran, our resident auto sparky here at Coreoffroad. KP, what's one of the first topics, mate, we're going to be talking about?
I guess, Jimmy, the biggest thing we probably need to touch on first is batteries. Sizing, what you need, how we can utilise it, to make sure your electrical system is sorted and ready to go.
And look, it's the same thing. There's heaps of information out there and there's forums and everything where everybody has an opinion on what type of battery, how big it has to be. We're not going to be diving into a lot of the technical stuff today. What we're going to be covering is some outline or a basis of what you need, and it's all going to be done off lithium power. Right? These days with GVMs and payloads, everyone wants to carry more and more weight with them. Lithium, it's the future.
Lithium's the way to go. It's just cutting down that weight from your traditional batteries to a lithium battery system.
Yep.
Saves you massively when it comes to your overall tier weight that you are carrying.
Yep. And touching on, I guess, battery sizing now, we build our power boxes, right? They've got 100 amp hour lithium in the PBO2 and 125 amp in the PBO1 models. What kind of capability are we going to get, or what can we do with 100 amp hour lithium?
Yeah, so with 100 amp hour lithium, you're not so much restricted based on the size. You can still run a fridge, you can still run a few lights, all that kind of stuff. When you're starting to look at obviously getting into items that draw a lot more power, that's when you need to start looking at the 125 amp, the 200 amp hour to give you that capability for storage and also the capacity to run what you are running.
And it all comes down, one of the key topics we've got is maintaining your system. You know, so I guess the battery size, it all depends on what you're running off your system. If you're running 2 fridges and you want to run an inverter, well, your battery needs to be sized accordingly. It really does come down to each individual setup and what the customer's trying to do.
Yeah, you know? Exactly.
So the biggest system we've done was a 400 amp hour lithium system. Heaps of solar.
Heaps of solar on that one.
Massive inverter, you know, but the customer was running induction cookers, big inverters, coffee machines, all that kind of jazz. So each and every one of your systems is going to have to be set up or tailored specifically to you. Now, trying to get the right advice in the industry sometimes can be difficult, and there is a lot of opinions out there.
Definitely.
So today we're going to touch base, I guess, lithium battery sizing, solar.
Solar's a big one.
Solar's a big one, and like one of our dot points we've got here, or one thing we see a lot of with customers, how much solar do they need? You know, so what sort of system, if we were running, say, one single fridge, Kieran, and we had a 100 amp hour lithium battery, what sort of size panel would we need to maintain that system?
Look, when it comes to maintaining the system, I guess the biggest thing you've got to work out first and foremost is what your fridge or your items is actually going to draw.
Yeah, what strain you're putting on the battery.
Yeah, exactly.
You know, we did a bit of prep work here before filming started, so we've got some figures. We based it off a standard 85 litre fridge, you know, which is going to be drawing around that 4.5, 5 amps. We've got it noted down as 4.6. So,
and just note, these are all ballpark figures. It's all dependent on how your system's actually installed as well. That can also affect the draw.
And ambient temperatures as well.
Ambient temperature.
One thing a lot of people don't factor in is ambient temperatures of their fridge. You know, if your fridge is sitting there baking in the sun on a hot day, it's pretty well going to run 100%. So what we based it on was 50% cycle. So a fridge that's drawing 4.6 amps, that's going to be cycling 50% of the time. Now in WA today, we're about 25 degrees. It's not too hot. So a typical fridge would cycle at around 50%. Over a 24-hour period, we're going to draw from our system around 55 amps. So to maintain our system, what do we then need to look at doing?
You've got a few different options when it comes to maintaining the system. So we've got a couple of figures here we just ran really quick. So first off, to maintain, you're going to obviously look at either a vehicle input, which then can come back to your DC chargers you have in your vehicle to allow, which can range anywhere from kind of 20 amp around about 40 amp input. Also, your other option obviously is solar.
And solar's a big ticket thing. We have a lot of customers say to us, how much solar do I need? And once again, it goes back to each system is different. Everybody's 12 volt setup is going to be different to the next bloke. So old Bob down the road, he tells you he's got a 100 amp hour lithium battery and a 100 watt panel, and he's never ever goes flat. Your 12 volt system is more than likely going to be different to his.
Yeah, exactly.
So based off our figures for that fridge, you know, we're pulling 55 amps over a 24-hour period. To have a maintained system, we want to make sure that even when we're camped up and we're not moving, we're putting in more than what we're going to be drawing.
Yeah.
That's the key factor. So when you are looking to set up your solar system, the main thing is to make sure that you are maintained. Now, we went off a 100 watt solar panel, all right? Whether it's a blanket or a fixed panel. On average, you're going to be putting in around that 5 amps an hour. Now, what's one of the key factors here with solar?
With solar, you've got to base the solar off a rough guesstimate as to what your sunlight hours are going to be.
Yep.
To give you what you're actually going to put back in.
Yep.
So when we're working this out, we kind of base it off roughly about an 8-hour day.
Yep.
As a peak.
Yep.
You know, depending on if you parked up in a little bit of shade, that obviously throws it out a little bit.
Yep.
It all comes down to, obviously, you've got to be able to have the input for the solar, also have a provision there to, if you are parked up in the shade, you haven't got the direct sun, to be able to gain direct sun, which is why we always recommend, if you are going somewhere, carry a portable blanket with you.
One thing a lot of people don't factor in, and we see it with customers with caravans and with their canopies and everything like that, it's human nature to park in the shade. If it's 40 degrees outside, you're not going to go and park in the sun. You're going to try and stay cool, get out of the sun, and that's one thing a lot of people don't think about. That's all. So one of the main tips I'd have for solar systems is oversize it.
Oh, definitely.
If you think that 150 amps, for example, is going to make you be able to maintain your system, put 200 in. Because whether it's a fixed panel, for example, on the top of a canopy or a caravan or camper trailer, as the sun rises, you're not going to get 100% efficiency out of that panel. You only may get 100% efficiency over a 4-hour period. As the sun is directly above the panel, then it's going to taper off. So the figures that we run off over an 8-hour day, it's underrated.
It is.
Really, you know, because you want your solar system to be able to produce more than what you think it's going to.
Yeah, exactly. And that's where the benefit of oversizing the system where you can comes into play. Because if, like you were saying, if you might only get 4 hours of that direct sunlight, if you can oversize it to, say, a 200 system, when you only realistically need 100, you're going to effectively double what your input is. And if you only get that 4 hours worth of sun, it's going to give you the same as what your 100 watt panel would over that 8-hour period. So oversizing and factoring that in to what you're actually choosing for your solar makes a massive difference to be able to maintain your system efficiently and properly.
And as Kieran said, even if you do have a fixed solar system, that's great. We still say to customers, carrying a portable blanket can't hurt. No. You know, I know what it's like up north. If you're inland in WA in summer, you're 50 degrees. So there is no
you've seen me. I turn into a bloody lobster.
KB's got a reputation of getting burnt, shedding his shell, and then going back white again. So
I'll always look for that shade. It's in my nature, 100%. So when we say oversized, I totally agree.
And the I guess advantage of having a portable blanket, if you are parked up underneath a tree, you can run your portable blanket out. Set it up in the sun, because your fixed system that's on top of your rig, it's really not going to do much.
No.
So a few tips with solar systems. One, oversize it.
Definitely oversize where you can, and you have the capability to do it.
And also setting up your system so it does maintain what your estimated draw or load on your 12 volt system is going to be. You know, they're kind of the two critical things. I'm not diving into what type of cells are on your panel and which panel's good for this. And
we do that, we're going to be here for hours.
So just a broad overview. One of the next ones that we're going to talk about is inverters. And customers say to us, well, how big does the inverter have to be? You know, so what sort of tips or advice have we got for everybody, mate, on sizing their inverter?
Yeah, so when it comes to sizing your inverter, you've got to look at what you're actually going to utilise it for. Now, if you're, for argument's sake, just want to run a coffee machine periodically, you'd start looking around that 1500 watt size inverter.
Yeah.
If you're starting to look for induction cooking and induction cooktops, stuff like that, we always recommend bigger.
Yeah.
2000 and upwards.
Yeah.
It gives you that capability to be able to run it efficiently
Yep.
and effectively.
The whole induction cooker thing is the biggest phase at the moment, isn't it?
Oh yeah, definitely. There's positives, there's minuses to it. You know, that's a whole different topic.
Yeah,
Trust me.
there is. We're not going to dive into it, but the induction cooker side of things, it's not impossible. It's quite easy to set up.
Yeah.
But you need to size your 12 watt system accordingly. So, you know, customers of ours, if, you know, somebody comes in and says, look, I'm looking at a GTU canopy, like the one behind us, I want to run induction, what are they looking to put into their canopy? Battery-wise and inverter-wise?
You know, it's like I said, if you are looking to run that induction, you're going to want to try look at a 2000 watt inverter and above.
Yep.
My recommendation, obviously, is if you are looking for that sizing and to run an induction cooker, because you're not just going to run it for 2 minutes.
Yeah.
It's going to be 10 minutes, 15 minutes to cook a proper meal.
Yep.
You're going to want to look for a 200 amp hour and above,
Yeah.
system for your battery wise.
Yep.
And then you're also going to want to look at maximising your solar
Yep.
as much as you possibly can. You know, like we've had customers, there's 540 watt solar we're putting on their canopy.
Yep.
With a 2000 watt inverter, so he could run his induction cooker.
Yep.
Never had an issue.
Yeah, and having that, you know, that 540 watt Energive system on the top of his canopy, he's putting in around 25, 27 amps an hour. It's phenomenal.
Yeah, it was massive.
You know, so that once again goes back to solar panels and doing your best to try and maintain your system.
And then it also sticks back to your batteries as well.
Yep, having the storage.
Choosing your right size battery.
Yep.
You know, all these things that we're talking about today all factor into each other.
They're variable depending on what you're doing.
Yeah, but they all factor in. There's always a little tie in between what your solar's going to do with your battery, what your battery's going to do with your induction cooker.
Yep.
It all kind of circles around. So it's stuff that you need to think of.
Yeah.
And it's like I said, this is all our recommendations.
Yeah.
Just to try and maximise and get yourself out there to be able to do what you want to do.
Okay. And look, if you're running small household appliances, whether it's a small hairdryer or something like that, your battery system, off say 100 amp hour lithium, can run a 400 or 600 watt inverter, no issues.
Yeah.
The one tip that I've got for you with inverter draw, and it's very simplified, take the wattage of your appliance that you want to run and divide it by 10. Now that's going to give you the DC amps in current draw. So if I had, say, a 1500 watt coffee machine, for example, divide that by 10, on average I'm going to draw 150 amps an hour of DC current through my inverter, transfer it to 240 volts AC to run my 1500 watt appliance. Now, they're massive numbers.
Oh, they're huge, mate.
Huge. Like, as an example, we've got this customer's GTU canopy behind us. Now, it's got 200 amp hour Energive, BTEC, 2000 watt inverter, same as the one in front of us here. We're running a cheap Tefal 2000 watt induction cooker. Now, what sort of numbers are we getting? It's phenomenal.
We both laughed at this just purely for the fact that we weren't expecting it.
Yeah.
You know, so we ran it on, it's called setting 5, so it's about half its nominal output.
It's
So
1,000 watts,
output's about 2100 watts on it, give or take. It was drawing 115 amps.
Yeah. It's massive.
Now, when you start looking at running it full noise, you're going to go 185 amps. Now, you've got to take that back again once to your sizing of your battery.
Yep.
You're drawing 185 amps out of your battery.
Yep.
That's a massive draw.
Yeah. And like, it's the type of thing, one thing we've spoken about having Friday Arvo beers is the actual sequence of you camping. Now, you might drive all day, for example, and at 5 o'clock you get to your campsite. Now, by rights, your 12 volt system, by the time you get to camp, although you've been running fridges all day and everything like that inside your canopy or trailer, by the time you get to camp, you should be at 100%.
Yeah.
So the sequence from there over, say, a 12-hour period from when you pull up to camp first thing you're going to do is open it up, you're going to get a beer out of the fridge.
Oh yeah, I definitely would.
So then your fridge is opening more.
So and that once again kicks it back into the cycle.
Compressor kicks back in more often. So from that 5 o'clock point where we're assuming we've got no solar input and we definitely don't have any vehicle input. So now we're full standalone. So we're going to go through, we're going to run our fridge. By 6:30, 7 o'clock, we'll turn the lights on.
Yep.
We're opening the fridge more often because we're getting the beer out a lot more often. Probably the first two be 5-10 minute intervals. We've got the lights turned on, we've got the stereo turned on, then we're going to cook dinner.
Yep.
Now we're going to run our induction cooker, let's say for 15 minutes. All right. Out of that 15 minutes, you're still going to probably burn around 40 amps.
Yeah, definitely.
Out of your system. So then the lights stay on, right? The stereo stays on till you go to bed.
A couple of volumes
that's right. Then you're going to probably charge your phone.
Yeah.
Then you're going to get up in the morning. The first thing you're going to do is start opening the fridge again. All right. So the current draw up to that point is massive.
Yeah, exactly.
Say we're burning over that 12-hour period, say 25 amps for refrigeration. We've roughly said you've burnt 40 amps to run your induction cooker for 15 minutes. Right? But out of a 100 amp hour battery, we're done. By the time you even get up in the morning, you're almost flat.
Yeah.
So it's the sequence of how you use that system. You know, you're then going to get up in the morning and say cook brekkie for another 15 minutes again. With your induction cooker,
there's another 40.
There's another 40 amps. So these are the things, it's not impossible, but these are the things you need to factor in. You know, I would say as a minimum, customers running induction cookers, at a minimum you're 200 amps.
Oh, definitely.
Of lithium. You would not go any less.
No.
You know, running a coffee machine, no dramas. Yeah. You know, because it's short, it's periodic, unless there's 10 people around the campsite, and you're the only one with a coffee machine, which is normally like
me. Go away with you.
Yeah. So I get up in the morning and make 10 cappuccinos for everybody. So having your system set up correctly is critical. You know, it's definitely not impossible. As I said before, a 400 amp hour system, no worries.
No.
You know, so, but it's that current draw, and like their numbers today,
yeah,
180 amps, that's next level.
Yeah.
You know, so I guess that's what we're trying to do is give you guys at home some awareness.
Yeah.
You know, what other tips or what else can we let the viewers know about 12 volt systems? Like one of the things with 12 volt systems, we say to people all the time that information is power. The more you know about your 12 volt system, right, the better you're going to do and the less chance you're going to have of having issues and refrigeration dropping out and dramas with batteries and maintaining everything. So what can customers do to get that information about their 12 volt systems?
You know, there's a lot of different options out there. You can run Bluetooth monitors, that kind of jazz. We run, so predominantly for our builds, we're running Inverter E-Pros.
And they're standard in every canopy, aren't they?
Yep. So the beauty for us with running those E-Pros, it gives us everything that we want to know to, once again, that information is power.
Yep.
You've got your current going in, your current going out. It shows you as positive when it's going in, then it's negative when it's going out.
Yep.
It'll show you your power draw, how long you've got until you're going to run out of battery.
Yep. How many hours till you're empty, based on your load, on what you're drawing.
And that's the thing, they're simple to use.
Yep.
They give you all the correct information that you want to be able to go, all right, this is what my system is doing.
Yep.
And that's the beauty of, as once again, information is power.
Yep.
The more you know, the better you can set your system up to be able to maintain and get out there and enjoy being outdoors, which is what we all love.
You know, and if you're running a 100 amp hour battery with your Enerdrive E-Pro, right, and you turn your 2000 watt inverter on and it tells you got under an hour, you know that you're no good. You know, so even with your solar systems, with the Enerdrive E-Pros, if your solar system, say, putting in 10 amps, for example, and I've got my fridge running and I've got some lights running, it'll actually tell me that I'm still putting in 3.5 amps, for example.
Yeah, so it all balances itself out with the algorithms that's got in it.
Yeah.
So it tells you that you're still, even though you're drawing 20 amps for argument's sake and you're putting in 25, it will show you you've got positive 5 coming back in your system.
Yeah, and that's when you can check that you are sustainable, and with your solar system, you can maintain your system.
Exactly.
Because that's what it's all about at the end of the day. So, few tips: oversize your solar system. That's probably a big one.
Yeah.
Selecting the right size battery for your system.
Oh, definitely selecting the right size battery for me.
Yep.
I think that's a great tip.
Yep.
Just purely, once you can work out what you're going to use in your system, size the battery accordingly and oversize it again.
Yep.
To give you that storage.
Yep. And with inverters, so current draw, so take the wattage of your 240 volt item, divided by 10, and that's how many amps of DC current you're going to be drawing out of your 12 volt system. The next one is information is power. So a few tips for you, all right, as a bit of a baseline without getting into the nitty gritty and all the jargon about technical specs and sine wave and everything, without going too far. A few tips for you to try and make it easier for you to set your system up so you can get out there and explore more. That's all. Thanks for tuning in, guys. Once again, hit the bell notification below to subscribe and stay in tune with all of Core Off-Road's latest videos, builds, and of course, shop talk. Thanks for tuning in.